Hey guys, Mr. Gomes here. It's late at night here. My kids are asleep. I am feeling better. Most of what I've been struggling with here is just feeling super tired and having a lot of drainage. So we'll see how things turn out. I hope you guys are doing okay at school. So typically, I go through these notes on classifying matter. Um, while I'm doing a lot of demos. Obviously, I'm not at school, so I can't do those. So I'm going to go through this fairly quickly. You can take notes down or not. You can use this video as reference, pause, rewatch as many times as you want. I'm just going to power my way through this and then just have that out there for you as a resource, okay? As we learn the basics of matter. So here we go. So our goal here for today is how do we classify matters? What are different ways that we classify matter? All right, so matter basically is anything that has mass and volume. Okay, so all things that we see are made up of matter. Matter would be, of course, the opposite of energy. I wouldn't say opposite of energy, but energy doesn't occupy, space and things like that. But matter does. Matter has volume. Okay, and matter is made of atoms. All right, so there we go. Definition of mass and volume. We just talked about it. All right, so all matter has properties. Okay, so physical properties typically are observed without changing anything to it. Chemical properties typically have to do something with the substance changing. Okay, pure substances typically contain only a single type of matter. Okay, whether it's an element or a compound, it doesn't matter, but it's the same particle over and over again. And hopefully you picked that up from the POGL that we did. And that set or that sample of the pure substance that you have will have the same properties all throughout, as opposed to something like a mixture. All right, so the periodic table is called the periodic table of the elements. So if it is on the periodic table, it's an element. If it's not on the periodic table, it's not an element. That's as simple as it gets, okay? So if something cannot be broken down any further into any simpler substance, then you've got an element. Yeah, okay, so elements cannot be broken down physically or chemically. Atom, of course, is the basic building block of everything. We'll be talking lots about atoms this year. Compounds are composed of two or more different elements joined by chemical bonds. Oops, I went too fast. So see here in these chemical formulas how you can have a subscript like this, but the letters are close to each other. So that means that those elements are joined by chemical bonds, okay? And each capital letter represents a different element. Sometimes you have lowercase letters like sodium and then chlorine, okay? All right. The property of a compound will be different than the property of the elements because that chemical bond changes things. Okay, so hydrogen, for example, is explosive and water puts out fire. Okay, but water has hydrogen in it. Compounds will have chemical formulas and they can be separated chemically. So we can put water, for example, if you put a 9-volt battery in water, you will start breaking down that water into hydrogen gas and oxygen gas. Okay, but that's a chemical change. It's not a physical change. Okay, so compounds can only be separated chemically because you have to break that chemical bond in between them. Okay, and the chemical bond is an attraction involving the outermost electrons of any two or more atoms. And we are going to talk lots about bonding this year. All right, mixtures. Mixtures is a combination of two or more pure substances that are not chemically bonded. Okay, they're joined by chemical forces, or physical forces, not chemical forces. And there's many ways to separate a mixture. Okay, some of them are called distillation, chromatography, which hopefully we'll get to do a chromatography lab, crystallization, magnetism, filtration combinations. So hopefully when I get back to class, I'll be able to demo some of these for you guys. All right, so mixtures. We can have homogeneous mixtures, which can also be called solutions. So homogeneous and solutions are synonymous terms. Or a heterogeneous mixture. So in a homogeneous mixture, everything's pretty even all throughout. Okay, in a heterogeneous mixture, you can tell the different parts. Okay, you can tell the different parts in a heterogeneous mixture. So like we said, homogeneous is uniform composition and properties all throughout. They're in the same phase. So if you put salt and water, the salt dissolves and becomes part of the liquid phase. Air that we breathe, okay, is a pure, not pure, is a homogeneous mixture because you can't tell the different parts, okay? It's all in the same phase. You can't distinguish one gas from the other. Homogeneous mixture, you typically have a solvent, which is what does the dissolving, and a solute, which is something that gets dissolved. All right. Now, alloys, people typically don't think of this, but you can have metals that are mixtures. So, for example, wedding bands, they're not pure gold. Okay, so pure gold over here on the top left, it's called 24 karat gold. It scratches more easily, it's a little bit softer. So to make more durable jewelry, they usually insert it with some silver and copper. So actually this gold here is 14 karat, which means it's really only 58.3% gold. So you melt all those metals, you mix them together, and you let them solidify again. And that's called an alloy, and it's a homogeneous mixture. Okay, it's a solution. Steel, brass, bronze, okay, are good examples of alloys. Heterogeneous mixture is a mixture that is not the same all throughout. Okay, great example would be Italian salad dressing, or just the salad itself. Okay, any mixture that is not the same all throughout. You can have two types of heterogeneous mixtures. So suspension. So some of you may have had a medicine where you had to like shake it before you took it. You can see the particles kind of float, but then they settle again. So that's a suspension. A colloid is something that looks like it's dissolved, but it's not really. Okay, and then homogeneous, everything is dissolved. We have those small size solute particles. Another good example of a suspension would be like orange juice with really thick pulp. If you let it sit in the fridge, you can see it settle in the bottom. You have to mix it back up before you drink it. Okay, so here's an example, okay, of a suspension. Precipitate, we're going to talk about this more. Precipitate is a substance that's insoluble and usually settles at the bottom. Okay, so precipitate is at the bottom of a solution. If you think of precipitation as rain coming down, when you have an insoluble solid in a container, it'll settle at the bottom. Okay, so that's called a precipitate. All right, and this, we're getting close to the end here. So the colloid and the Tyndall effect, which hopefully I'll get to demo for you guys as well. So sometimes it's hard to tell a colloid from a homogeneous mixture. For example, is milk a homogeneous mixture? Well, one example is, one test is called the Tyndall effect. If you shine a flashlight through a homogeneous mixture, the light will go straight through it, okay? But if you do it through a colloid, which appears to be homogeneous, the light gets scattered. Okay, so that's one way that you can tell a homogeneous mixture from a colloid, which is a heterogeneous mixture. Okay, because the particles are not totally evenly dissolved and spread out throughout each other. They just kind of have that appearance because we can't see them well enough. Here's a quick review. Elements, you only have one type of atom. You can't break them down anymore. Compounds, you have two or more different types of atoms chemically bonded. Excuse me. Yeah, the only way to separate them is through chemical means, and the compound does not share the properties of the elements that make it up. Excuse me. Like I said, I have a lot of drainage. Mixtures. You can have two types of mixtures, okay, heterogeneous or homogeneous. You can have a mixture of elements, a mixture of compounds, a mixture of elements and compounds, okay? Mixtures are separated through physical means, not chemical, because they're not chemically bonded, they are physically mixed. And when they are mixed together, each substance keeps its properties, okay, unlike the compounds. All right, that's it.